Hi, and welcome to day 3 of making and observations from data in ScatterPlots. We're continuing our RPS at home lessons for 8th grade math. SOL objective is 8.13b. We're making observations about data represented in ScatterPlots. You're making these observations about a set of data points in a scatterplot having a positive linear relationship, a negative linear relationship, or no relationship. In discussing yesterday's homework assignment, the correct answer for finding the data points for the Chapter 8 test grades was located in the second table at the top right. So if you were to look at the graph, at 0, you should have had a point at 50. At 1, you should have a point at 73. At 2, 85. 3 hours studied was at 90, and 4 was at 98. For question number 2, you were supposed to write down all coordinate points that make up the data set represented in the scatter plot. I ask that you please look at the data that is the answers to the data that is recorded here and compare that to what you have. Please refer back to the table and the coordinates that are there if you have any questions or concerns. Today's objective, I can analyze a scatter plot to determine whether the data has positive correlation, a negative correlation, or no correlation. Materials needed: paper, preferably that of graph paper, and a pencil. We will now move on to today's instructional video. After we go over our vocabulary for the week. Those vocabulary terms that we need to reference are independent variable, dependent variable, line of best fit, positive relationship, negative relationship, or no relationship. We also share with you these pictorial representations. Remember that as the line is increasing, that is considered a positive linear relationship. If the line is decreasing or has a downward trend, that is a negative relationship. Or if the points are scattered about the graph and there's no real correlation between the x and y coordinates, that is considered no linear relationship. We ask that you please take out your paper and pencil at this time and prepare to watch today's instructional video, take notes, and come back to the video when you are ready so that we can start on your independent practice problems. Please watch the video at this time.
But today we're going to start with just collecting data and very broadly analyzing data. So starting with talking about scatter plots, there's a couple key points that we want to talk about here, and filling in these blanks, we're going to start by saying that a scatter plot illustrates the relationship between two sets of data. The scatter plot is going to consist of what are called ordered pairs. We're also going to call them data sets, but for now we'll just stick with something we know and say they're ordered pairs. And within these ordered pairs, the x and y coordinates, so the x and y coordinates are going to represent the measures of the two attributes of the point. So the x coordinate stands for one thing, while the y coordinate stands for something else, because it's going to be data-driven, data-related, so it's going to be real life saying this means this. Scatter plots can be used to predict patterns and estimate lines of best fit, or a line of best fit. So seeing the trends in the data can say, well, I think this would happen in this instance based off of everything else that's happened up to this point. In a scatter plot, each point is represented by an independent and dependent variable. This is data that you can collect through experiments. So the independent variable is something that you change, and the dependent variable is something that you measure as a result of that change. The independent variable is going to be graphed on the x-axis, whereas the dependent will be graphed on the y-axis. So anything that you can change with an experiment is going to be your independent variable, and anything you can't change will be your dependent variable. Within these scatter plots, what we're going to see is, based off of this data collection, we're going to see 3 different types of relationships, and they're all going to have to do with what's called a correlation. A correlation is just something that measures that type of relationship. So we can have 3 types. We can have a positive, we can have a negative, or we can have no correlation. So with a positive correlation, what you see is a collection of data that looks like it has a type of positive slope. So in this case, if you were to draw a line to your best ability through these data points, it's going to look something like that. So as x increases, if we think about how slope works, a positive slope means as x increases, y also increases. A positive correlation has that positive trend where one goes up, the other one goes up, and the line and the trend of data is going up. A negative correlation is going to be just like a negative slope, where it's kind of going down. So it doesn't have to be such tight data points like I have here, but if you can just see the general trend of that data going in a downward direction, that means you have a negative correlation. So as x and y change, with negative, it's going to be like negative slope. So as x still increases, because we're always going to read x from left to right, in this case, we are now going down. So y is going to decrease as x increases. That's that negative change over positive time. So the difference between positive and negative, x is always going to increase when we read this, but positive means y goes up, negative means y goes down. Finally, with a no correlation, what we have with a no correlation is just a random collection of points that do not follow any particular trend. So no correlation has no obvious pattern. I could not draw a line through that collection of data because it doesn't show a positive, negative, or a zero trend. The points are just all over the place. There is no obvious pattern. As we go through a couple examples, we're just going to label these as positive, negative, or no correlation relationships. So what we're asking ourselves with each one of these is, as the independent goes up, does the independent go down or up, or does it not be affected at all? So in our first case here with shoe size and math test score, it doesn't necessarily mean that the bigger foot you have, the better or worse you're going to do on your test. So in this case, this is no correlation. This is no trend. The height of a basketball player and the number of rebounds. What we can say in the general sense is that in the game of basketball, the taller you are, the more likely you are to get a rebound because you can reach higher than other people. So we're going to give this a positive trend. Taller players get more rebounds. Outside temperature and heating bill. This is going to be negative because as the temperature on the outside goes up, so as it gets warmer outside, you're going to use heat less. So your bill will go down. So that's a negative trend. Eye color and test score. Again, this is a no trend because as your eyes increase in color, which first off doesn't make a lot of sense, that doesn't mean your test scores are going to increase or decrease. So that'd be hard to measure in the first place. Finally, time spent studying for test and test score. We're going to end with this as positive because we see in a general sense, the more you study for a test, the better you do on that test. That will be a positive trend. Now what we're going to do is we're actually going to create our own little scatter plot. We have our data points over here, so we're going to take these 7 and we're going to fill them in over on the grid that's provided. But the first thing we have to do is we have to label our axes. We have to know which points are going where. So the one thing that we're going to control, the one thing we're going to label here, is TV time. How much time is spent watching TV? And the dependent variable is going to be our homework time. How much time do we do homework as a result of watching so much TV? So as we go through here, and we're going to fill in these data points one at a time. When we watch 2 hours, we're going to watch 30 minutes. And we're going to keep going here, so I will fill in this if you'd like to pause the video and try to do it yourself real quick, and then you'll see the answers. All right, so there's our data, and looking at the scatter plot, we are now going to respond to these 2 questions on the bottom, then we'll be done for the day. First off, we're asking if there's a relationship between time spent watching TV and time spent studying doing homework. If you look at this data trend, what you should be able to see fairly well is that we have this line kind of going like that, or if we try to draw it just a little more straight, we have this line kind of following this. And we're going to talk more about line of best fit later, but what you should be able to see is the data's kind of following that trend. So what we have is we actually have an example of a negative correlation. And the reason we have a negative correlation is as you watch more TV, you study less. So that's the example of a negative correlation. As TV time increases, homework time decreases. You watch more TV, you do less homework. So that's our negative correlation there. If a student spent 4 hours studying, how much time might they have spent watching TV? So this is going to be one of those predicting patterns type question because we don't necessarily have anything up at this 4 hours of study time. But by looking at the trends of the data, we can definitely say you're not going to watch 4 hours of TV and do 4 hours of homework because there's nothing near that data trend. What's more likely to happen to have 4 hours is it's going to have to be something similar to 3 hours of study time. And since we can't watch a negative amount of TV, what I'm going to say and what our answer kind of makes sense to be is if we have something around this range. So I'll say about less than 30 minutes of TV. Because we can give ourselves a little wiggle room because we see that there's two different data sets that have the same TV time but two different study times. So we can say that you can maybe watch 10, 15, 20 minutes of TV and still be able to get 4 hours of homework time in, even though one person never watched TV and got 3 hours in. So it's just that estimation, it's just that reasonableness that's about reading scatterplots and creating scatterplots. So that's going to be our review today on scatterplots and correlation. And
Now we are ready for our independent practice. Here is example number 1. Classify the scatter plots as having a positive, negative, or no correlation. We ask that you please pause the slides for a few seconds, write down your responses, and then we will go over your answers once you're done. These are the solutions to your questions. If you notice, number 1 is all scattered about, so there's no correlation. Number 2 was negative correlation. Number 3 is an upward trend, so it's a positive correlation. Number 4 is a positive correlation. 5, negative. And 6, there is no correlation. Example number 2, we ask that you please identify each scatterplots data with a negative that has a negative relationship.
So the question here is asking which scatter plot shows data with a negative relationship. So remember, a negative relationship means that as one thing is increasing, the other one is decreasing. So if we look at this first option here, scatter plot A, the dots are kind of all over the place. There's not really a pattern. There's no clear understanding of what's going on between our age and the number sent for text messages. Looking at scatter plot B, this is describing the weight and how much the vehicle would cost. So if you look here, we have a trend going up. So as the weight is increasing, the price is also increasing. So this here would be a positive relationship. Scatter plot C, this is the number of states since the year 2000. There are 50 states, and you'll notice that every year since the year 2000, there are still 50 states. So that is not changing. And looking at scatter plot D, this is water in a container. So this is the amount of time in minutes and the amount of water in gallons. So as my time goes on, as my time increases, the amount of water in that container is decreasing. So this one here would be a negative correlation between the two.
All right, now we're on to example number 3. Which type of correlation is shown in the scatter plot? So look at the trend and identify which correlation is determined to be shown in the scatter plot. The solution is that it is a positive correlation. As the X values increase, the Y values also increase. I hope this is the answer that you have came to the resolve for. We're now ready for our practice and homework. For the first question, you are given 6 graphs and asked to identify each scatter plot that shows a positive relationship among the data sets. And for second question, it says a group of students collected data on a school field trip. Which of the following data should most likely result in a scatter plot having a negative relationship? We ask that you please take a few seconds to pause the slides and to respond to these 2 practice/homework questions. We will go over the responses to them during tomorrow's lesson. As always, we ask that you please log on to Dreambox at this time to complete at least one lesson. Remember, Dreambox is located in your Clever account. Thank you so much for joining us today, and we look forward to being with you tomorrow.